Shamasei. I recently related the Hobbit movie with the elves and dwarves to the mythological world tree and the Holy Grail. So this article that I found here is kind of interesting about these new lasers. Here it is. Konnichiwa. I saw this article about a new type of laser beam, and it gives an interesting example with spoons and light bending. It says University of Central Florida researchers have developed a new type of laser beam that doesn't follow long-held principles about how light refracts and travels. The findings, which were published recently in Nature Photonics, could have huge implications for optical communication and laser technologies. Quote, this new class of laser beams has unique properties that are not shared by common laser beams, says Ayman Aboradi, a professor in UCF's College of Optics and Photonics and the study's principal investigator. The beams, known as space-time wave packets, follow different rules when they refract. That is, when they pass through different materials. Normally, light slows down when it travels into a denser material. Quote, in contrast, space-time wave packets can be arranged to behave in the usual manner, to not change speed at all, or even to anonymously speed up in denser materials, Aberrati says. Quote, as such, these pulses of light can arrive at different points in space at the same time. Quote, think about how a spoon inside a water-filled glass looks broken at the point where the water and the air meet, Aberrati says. The speed of light in air is different than the speed of light in water, and so the light rays wind up bending after they cross the surface between air to water, and so apparently the spoon looks bent. This is a well-known phenomenon described by Snell's law. Although Snell's law still applies, the underlying change in velocity of the pulses is no longer applicable for the new laser beams, Abrati says. These abilities are counter to the Fermat's principle that says light always travels such that it takes the shortest path, he says. Quote, what we find here, though, is no matter how different the materials are that light passes through, there always exists one of our space-time wave packets that could cross the interface of the two materials without changing its velocity, Abrati says. So no matter what the properties of the medium are, it will go across the interface and continue as if it's not there. It's interesting with the light and the spoons. Okay, thanks for watching. Arigato, matane.